Hi friends, welcome to follow up. In this video, we are going to have a look at problem 3135, equalize strings by adding or removing characters at ends. So in this video, we are going to transform this problem into a prototype problem and then use dynamic programming to solve this problem. So here, before we start, I hope you have heard the longest common substring of two strings, right? Or two lists, something, two strings. Let's see. So we the typical problem is that find the length, or you can even find the longest common string. So the longest length typically is unique, while the corresponding longest common substrings is not unique. So let's use an S here. So typically for such problem, we can use dynamic programming to address it. So for this problem, let's see the connection with the longest common substring, and then we also explain some thoughts. So let's quickly look at the problem statement. So here we have two strings. One is called initial and the other called target. So our task is to modify initial by performing a series of operations to make it equal to target. So in one operation, you can add or remove that character only at the beginning or the end of the string initial. So this is a very important paragraph or sentence. This basically makes the connection of the current problem with the problem or prototype problem longest common substring of two strings. So here we want to return the minimum number of operations required to transform initial into target. So let's look at example 1. So if you look at example 1, we know that the common part for this two string is CDE, right? So in other words, so we can move AB at the very beginning and then add F at the end, right? So we have A, B, C, D, E, and we have C, D, E, F. So the longest common substring is, let's see, C, D, E, right? So the length is 3. So the A, B, C, D, E have length 5. So this length 5, and this is length 4. So the result will be 5 minus the longest common substring, and then plus the second length minus the common string. That's 3, right? So this is nothing but the two lengths sum, right? So minus 2 times the length of the longest common substring, that is 3. So in total we have 3. So this is example 1. So now if you look at example 2, right? So we have AX as Y, and we have Y ABX. So the longest common substring, so here is just a Y, right? Or you can see A, right? So but typically we'd better to see we use this part, and then so here, and then we get a piece from here. So we have Y. So but notice that here A and have the same length, right? So if you do this, so it will give you the same result. So here the length is 1. So each length here is 4 and 4. So what you get for this result is going to 4 plus 4 minus 2 times 1. So here is a detail, because for the longest common substring, so the length is unique, while the longest substring is not unique. For example, here, so we know A is a valid common substring, its length is 1, and Y is also 1, and X is also 1. But what in our mind actually is 1 Y, right? Because we remove these 3 letters, and then add these 3 letters, so total is 6, right? but this does not affect the result, the final result. So it's good to digest this part. This point here. This is example 2. So if you look at example 3, so this is a special case. So these two are identical at the very beginning. So typically we need, for sure, we need to use need 0 additional operations. So here the common string have length 3, right? The lengths are 3 and 3 respectively. So total is 3 plus 3 minus 2 times 3 is 0. So that's the overall problem. So now you notice that the constraint, so the initial and the target both have lengths bounded above by 1000. Maybe if you just try to some brute force, so you see, for example, you use a certain length to see if you have that length common string and you find the largest length. That might be possible, but it's not what. So for this problem, it suits the dynamic programming idea. So initial and target consist only of lowercase English letters. So if we think of this longest common substring, so this is not a very essential one, right? So with that said, we are ready to do the coding. For the coding, we first find the length of the longest common substring. So this is a prototype problem. So basically, it's not. It's actually very routine. And then what we are going to do, we use the sum of lengths minus 2 times the length of LCS. Right. So now with that said, let's first do the. I'm not going to write every detail, single detail for this this part, the length of the longest common substring. So here we're going to use dp anyway. So we have m and n. So this is the length of initial, right? And then length target. So what I'm going to do is I'm going to use dp. So I want to use this n as a number of column, n plus 1. So I'm going to use a dummy index for instance in range say m plus 1. So the first row and the first column will be 0. So here the dp interpretation will be the following. And dp ij is basically the length of longest common substring ending at index. So ending at exactly at index I minus 1 and j minus 1. This is for initial, and this is for target, right? So in other words, this is the length of the longest common string for initial length of the longest common string ending at this index for this one, for let's see, initial. I'm going to write here, maybe initial up to I, and target up to j. So notice that we require so the common string ending at exactly indices I and minus 1 and j minus 1 if we look at initial and target respectively. So this is very important because this interpretation determines our dp update rule, right? So because of this assumption, so let's write the dp update rule. So why the first row and the first column is 0? So you can imagine that each of the initial and target can start with some non lower English case letters and not equal. For example, star plus initial and hyphen plus target, something like this. So this way we actually save lots of check or coding. So dp update. So for I in range So we from 1 to m plus 1. And then for g in range, say 1 to m plus 1. Then what we are going to do, we are going to check if initial, because of the range, I is from 1 to m plus 1, so we need to use I minus 1, right? So if this equal to target j minus 1, so this means that dpij is not 0. Otherwise, if these two letters or characters does not equal, it means that the dpij must be 0, right? Because of the interpretation we require. Because due to this interpretation, we require if this dpij is not 0, then the corresponding character at i minus 1 and j minus 1 must be equal, right? So then if they're equal, so dpij will be 1 plus dp I minus 1 and j minus 1, right? So we want to find the longest length, right, of such string. So we can have length longest common substring. This is continuous, right? So it's a substring, so it's 0. And each time we're going to do longest common substring. Length is max this previous state plus the current this compared with the current dp state. So afterwards, we're going to get the longest common substring. Then what we want to return is actually return m plus n minus 2 times this number, longest common substring length. So this actually forms a solution format to this problem. So we can do a check, especially example 2, because this have longest common string length is 1, and it can have several different such strings like a and x, right, and y. But among them, there's one must be the one we desired, right? So now let's check one example. So this is for the first one. So now let's look at this one. So for this one, we know the two lengths are 4 and 4. So if we get the correct result, then the list variable should be 1, right? Let's check that. Yeah. So now let's look at the generic case. Yeah, it passes all the cases. So actually, in my first try, so I actually made this as the longest common subsequence, right? So that's actually caused the error. So if you want to, so here is an extension, right? So the two problem is given two strings. There's three actually. First, find longest common substring or their length. So this is actually so this is unique. So for longest common string, this might not be unique. So you can just locate one. This is a typical problem in LeetCode. Another one is that find longest common subsequence or their length. Same as the first problem. So their length, the longest length is unique. Well, the longest common subsequence is not unique, right? You can locate one. So this is another one. So if we want to do one step further, so you can find longest palindromic substring or subsequence, right? Or subsequence, or their length. So similarly, the longest palindromic substring or subsequence, palindromic, let me emphasize palindromic subsequence. It might not be unique. Well, the length is unique. So with that said, I guess that's basically about it for the current video. It would be great, or it would be helpful if you can code these problems and digest more. So basically that will be much better than doing this problem itself, right? So with that said, I guess that's basically about it for the current video. Thank you for watching.